Hello everyone, and I welcome you all to the 12th class session of the NPTEL course, Basic Environmental Engineering and Pollution Abatement. The course has been instructed by Professor Prasenjit Mondal from IIT Roorkee and myself, Chaitra Borkar, a Ph.D. scholar from IIT Delhi, and I will be conducting this session. So, some general information about these sessions that these sessions have been conducted every week on Saturday from 3 to 5 p.m. for the duration of this NPTEL course. And the live sessions link have been shared with you all. And these live sessions are recorded, and the recordings are made available to you through my YouTube channel. Let's now start with the overview of the lectures given for the 12th week of this NPTEL course. The lecture 56 was dealing with the air pollution management, air quality survey, and NAAQI, so which is National Ambient Air Quality Index. Firstly, the air pollution management was discussed, in which the aim of the air pollution management is that it basically deals with the reduction of airborne or gases or airborne gases, particulate, and biological pollutants. The air pollution abatement plan has a number of elements which can be detail of the particular area in which the air quality needs to be controlled. It can deal with the monitoring of the air pollutants which are there in that locality. It can also consist of the simulation of the concentration which can prevail in the area. It can also deal with the emission inventory. So, how much emissions are being generated during a particular time in that area, which is a detailed list of the emissions which are coming generated from that area. And it can also deal with the cost analysis, also the legislations which are present in that area. Uh, for the emission inventory, as I said, it is a database of the pollutants which are discharged from the area. And the procedure for the emission inventory preparation has 5 volumes. So, first volume is the emission inventory fundamentals, which gives the technical and the design aspects. Next volume deals with the point sources. So, what are the stationary sources which are there, or which are the area sources? Area sources are those collection of the point sources which emit relatively less concentration of pollutants. The mobile sources such as vehicles, and finally the bibliography. The air quality standards have two types, which can firstly establish limit on the source discharge or establish limit on the ambient air quality. So the controlling measures of air pollution can be either the modification of the fuel that you're using, or the processes or the equipment. For the industrial establishment, the controlling measures can be through uh, for the gaseous pollutant, it can be absorption through liquids, and adsorption over solids, and can or through by combustion. Uh, these have been discussed before. And for the particulate pollutant, it can be through gravity settlers, cyclone separators, filters, or scrubbers. The air quality management cycle have different steps which are shown here. So, firstly, we need to establish goals so as to see how much how much the emission is present, air pollutant emissions are present in a particular area, and based on that, how much is needed to reduce for the safety of the public and the environment. Then we need to determine those emission reductions. Next, we need to develop certain control strategies to achieve those emission reductions and implement those programs. And finally, undertake the ongoing evaluation, so that to check whether these program implementations and as well as the control strategies are effectively being used to meet these certain goals. Next, the legislative history of India for air quality management was discussed in this lecture, and in that we saw the different eras, which can be pre-internet era or the transition era or the internet era, in which different acts or different legislations were passed so that the safeguard of the environment as well as the animals or the human beings can be achieved through these laws. Next was the National Air Quality Monitoring Program, in which the firstly the history, the modification, and the development of this program was discussed. This plot here shows the growth of the different stations in the different parts of the country, which were added over the years. And we see that from 1984, when it was firstly implemented, this National Air Quality Monitoring Program, it was for two towns or cities, Agra and Anpara, and in that they had seven stations in total. And then over the years, it gradually increased by 2020 to 804 stations in roughly about 370 towns or cities. It basically, sorry, it basically monitors the regular and selected parameters, and it has 24-hour sampling, which is twice every week. So we get for a year 102 samplings. The continuous ambient air quality monitoring system is for, as the name suggests, for the continuous monitoring of pollutants, and it is useful in generating the daily national air quality index of the cities. The next, the air quality survey, its methods as well as advantages was discussed. So methods can be through it can be going on through the field and doing the survey, or taking some uh, uh, technical tools to make that survey possible. The advantages can be such that doing the air quality survey can tell you how much the air needs to be cleaner, and this air quality survey can help you in is also helpful in as the studies have shown, the cleaner air or air of better quality leads to better morale. It leads to more safety of the people working or people living in that area. And finally, the WHO air quality database was discussed. So this is a worldwide air quality database which has a exhaustive list of different air quality from different regions of the world. In the lecture 57, the National Ambient Air Quality Standards and the Air Quality Index were discussed. So the objectives of the National Ambient Air Quality Standards are such that it indicates the level of the air quality which is required, um, or which is currently present. Then assist in prioritizing the air pollution control. Next, the to provide the a uniform yardstick to assess air quality at national level and indicate the need and extent of monitoring program. So next, the evolution of the air quality standards in India were discussed. This schematic here shows the same. So firstly, when the air quality standards were introduced in 1982, it considered only three pollutants, which is SO2, NO2, and suspended particulate matter. Next, when these standards were revised in 1984, four more pollutants were added in addition to the previous three pollutants, which are the respirable suspended particulate matter, lead, ammonia, and carbon monoxide. Followed by another revision in 2009, in which a total of 12 pollutants were considered for generating the air quality standards. So in that, many other, like five more pollutants were added, such as BAP, benzoaphenyl, and uh, arsenic and nickel, and benzene. And finally, for 2019 to 24, the review of air quality standards planned under the NCAP is going on. So, the air quality index is a tool for effective communication of air quality status. So it basically condenses all the 24-hour emission data for different pollutants into a simple number which can tell us how what is which can tell us what is the air quality in a particular area. So the computation is done using the CAAQMS, as I had already discussed. Here, 8 pollutants are considered, which is PM 2.5, which have size less or equal to 2.5 micrometer, PM 10, NO2, SO2, carbon monoxide, ozone, ammonia, and lead, and has 6 categories, which are uh, good, moderate, satisfactory, poor, very poor, and severe. The formulation of AQI is done in 2 steps. Firstly, we formulate the sub-indices and then aggregate them. So this schematic here shows the formulation of AQI. So the hourly data for different pollutants is collected, and then we generate the sub-indices. And these sub-indices are then aggregated to form an AQI. So here, as the color coding shows, these pollutants, at least one of these pollutants should be there to calculate the AQI. And this green and orange color coding shows at least three should be present. So at least one of these should be present while calculating the AQI, and at least three pollutants should be considered to calculate AQI. You cannot calculate AQI for only two pollutant concentration if only two concentration of two hourly concentration of two pollutant is given. Uh, and if there are three pollutants given, one of them should be either PM 2.5, and PM 10. The different examples of AQI were also discussed, in which firstly the green index was discussed. It includes SO2 and coefficient of haze. Next, the Ontario Air Pollution Index was also discussed, in which also the inclusion of coefficient of haze and SO2 was there. Then the most undesirable respirable contaminants index was discussed, which only considers COH or coefficient of haze. Then Oak Ridge Air Quality Index considers SO2, NO2, particulate matter, carbon monoxide, and photochemical oxidants. Finally, the Indian Air Quality Index was discussed, which basically use in linear segmented principle, and for the calculation of the sub-indices, and then for the aggregation it uses maximum operator. So for aggregation, different types of operators or methods can be used. India uses the maximum operator method. It can also be in weighted additive form, root mean square form, or root mean sum form. So a sample calculation of AQI is shown here. This was also discussed in the lectures. I am just simply reiterating what was done in the lectures. So firstly, we need to calculate the sub-indices IP for using the linear segmented principle. Then the AQI will be the maximum of the IP. So here the minimum three pollutant concentration needs to be considered, and one of them should be either PM 2.5 or PM 10, as I have already discussed with you. The sample calculation for a given system is now being done. So we need to calculate the AQI for an area with 24-hour concentration of PM 2.5 41 microgram per meter cube, PM 10 58 microgram per meter cube, and SO2 9.5 microgram per meter cube. Now here we are given the table in which the AQI category, pollutants, and the health breakpoints are given. So for PM 2.5 for 24-hour concentration, these are the breakpoints. So if the concentration is between 0 to 30, then the AQI category can be good. And this is the index given here. So these are the breakpoints, and these are the index for a particular pollutant. So this is the breakpoint for a particular pollutant, and these are the indices, lower and the higher one. So we need to calculate firstly the sub indices IP, and then we need to see which one of them is the maximum one, and that will be the AQI. So here the calculation is shown. So linear segmentation principle formula is given here. So this is the index of the higher level, or the higher limit, and this is the index of the lower limit. This is the breakpoint of the higher limit, or the breakpoint for the lower limit. This is the concentration of the pollutant given, and this is the breakpoint at the low point, and this is the index of the lower limit. So for as was given in the question, for PM 2.5, we are given the concentration for 41 microgram per meter cube. So where does this lie? It lies between the breakpoints 31 to 60. Okay, so this is high, BP high. So this is BP HI, and this is BP LO. Now we have found the breakpoints. Now the indices here will be, for the higher indices and the lower index is, this is IHI, sorry, IHI, and this is ILO, and this is only for PM 2.5. Okay. For PM10 and then SO2, you need to then consider different IHI and different BPs. So for here we have found out the IHI, ILO, BPHI and BPLO. Now the concentration of the pollutant is 41 as given in the question, and then we can calculate the sub-indice for PM 2.5, which will be 67.896. Similarly, we can calculate the sub-index for PM10, which will be 58. How is it calculated? I'll show you here. So this will be, we know the given concentration. Given concentration is 58 microgram per meter cube. So where does this 58 lie here? So 58 lies between this 51 and 100. Okay. So the BP high will be this one, then BP low will be this one. So we are now, and the I high will be 100 and the I low will be 51. So 100 minus 51 upon 100 minus 51. So, and what is the CP? CP is 58. And this will be BP low is 51 plus I low is 51 for this case as well. So this comes out to be, as this cancel out, this becomes 1, and 58 minus 51 plus 51 will give us 58. Next, for the subindice for SO2 can be calculated from the linear segmented principle in a way that firstly you need to see what is the given concentration. So given 24-hour concentration is 9.5 microgram per meter cube. So where does this 9.5 lie? It lies between 0 to 40. So this will be BP high for the case of SO2, and this will be the BP low. And now this will be the I high, and this will be the this 0 will be the I low. So here you calculate it. So 50 minus 0, I high minus I low, upon BP high minus BP low will be 40 minus 0 into CP is 9.5 minus BP low is 0 plus I low. I low here is 0. So we get 5 by 4 is 1.25, and 1.25 into 9.5, it comes out to be 11.875. Let me just check it. Yes. So now we know the IP. So IP denotes the subindex for a pollutant P. So we need to find out now. We now know the subindexes for different pollutants. Okay. Now out of these, which is the maximum one? So this is the maximum one. So the AQI is equal to 67.896. So where does this lie in the AQI category? So AQI 67.896 lies in this, so it becomes satisfactory. The lecture 58 dealt with the management of special category waste. And the special category wastes are solid waste which require special handling or disposal. And in that, it discussed the biomedical waste or hospital waste. Firstly, the generation of these biomedical waste can be through different location in a hospital or a clinic or a nursing home or a dental clinic, and these can be either hazardous or of non-hazardous type. Different types of biomedical waste categories were discussed, which are 10 types. So here, category number one is the human anatomical waste, and the treatment and disposal method is through incineration or deep burial. And these treatment methods will be discussed further. The animal waste is the second category, which also requires treatment through incineration or deep burial. For the third category, which is the microbiology or biotechnology waste, the local autoclaving, which is sterilization or microwaving, and then incineration. The waste sharps, which can be needles or the scalpels, these need to be disposed of or treated through firstly disinfection with by chemical treatment, then autoclaving, microwaving, and mutilation, and then finally shredding. The discarded medicines and cytotoxic drugs are treated through incineration, then destruction and drug disposal in secured landfills. The solid wastes are incinerated, autoclaved, or microwaved. Next, another category, solid waste, can be disinfected by chemical treatment, autoclaving, microwaving, and mutilation, and then shredding. The liquid waste is firstly disinfected by chemical treatment and then discharged into drains. The incineration ash is disposed in the municipal landfills, and the chemical waste is treated by chemicals and then discharged into drains for liquids and secured land for solids. The treatment and disposal methods can be, as I have said, destructions or disinfection, and the disposal can be through secured landfill or deep burial or secured landfills or deep burial. The different disinfection methods were discussed, in which first was the autoclave method. Autoclave method is basically you have a high pressurized container in which there is a high temperature as well, and this uses steam to sterilize the given mass inside the autoclave. So different parameters such as d value, uh, which is the decay time, and then the z value, which is the coefficient of temperature, and the FO value, which is the equivalent exposure time, were discussed here. And then another method, which is microwaving, and this is a method which is generally used for solid which are not 100% solid, waste which are not 100% solid and dry. And the hydroclaving is another form, a type of autoclaving uh, which uses less steam and lesser energy, and other methods can be chemical treatment. The off-site treatment process includes incineration, land disposal, and deep burial. Here a schematic for deep burial is shown here. Here we see that trench or a trench is dug out from the earth of about which is 2 or 3 meter deep, and the almost half of this trench is filled with solid waste, and then above that we need to add the lime layer, and over that we need to put in the soil cover. The management of shafts was also discussed. So, firstly, shafts needs to be disinfected using chemical treatment, and then they either need to be mutilated or shredded, and then the disposal by burial in land. Lecture 59 dealt with the special category waste, which is the e-waste. So e-waste are discarded electrical or electronic equipment. Also, which the electrical or electronic equipments which are repurposed or recycled can be considered e-waste. So they are composed of various metals and non-metals, and roughly the concentration comes about 30% organics, 30% inorganics. Inorganics can be the ferrous metals or non-ferrous metals, and 40% inorganics and 30% ceramics, which can be mica and so on. Um, these different sources of e-waste can be there. So the non-functional electrical appliances in our home, or the discarded batteries, or it can be non-functional computers and so on. The constituent materials of e-waste can be precious metals and useful metals such as copper. Precious metals can be palladium. The hazardous material can be the example can be mercury here, or lead. Then toxic substances, and then plastics as and the glass material. The effects of different effects of e-waste were discussed, which and the exposure of these different harmful substances can affect different parts of the body, such as lead can affect the brain, the mercury can affect a number of organs in our body, arsenic can affect adversely, and different such as dioxin can also be harmful for the humans as well as animals. The generation of e-waste has been projected to increase in many folds in the coming years. So, the e-waste legislation in India was also discussed, and the e-waste management policy deals with the either reduction in the production or the disposal. So, the reduction in production can be achieved through different analysis method. One of them can be life cycle assessment or the multi-component analysis. Uh, Here, the e-waste management policy is shown. So we can check the imports and exports of the electronic goods. We can collect the waste, the proper waste collection, storage, treatment, and disposal. Then monitoring and evaluating the management policy, the legal framework which are being enforced, the the institutional mechanism which are there to manage the e-waste. The recycling of e-waste, different types of e-waste are present, and the different components can be recycled, such as plastics, they can be recycled or repurposed. Metals can be extracted and then used for different applications. Mercury can be used. Batteries which are containing lead and different metals can be the metals can be extracted and these can be used further. The circuit boards can have different metals and different materials which can be recycled. The different steps of steps including in the recycling of these e-waste were also discussed, and the different recycling methods were discussed, in which hydrometallurgical method, pyrometallurgical methods, biometallurgical methods, and electrometallurgical methods were discussed. So e-waste firstly needs to be go through some preparation, which is separation and disassembly. Then size reduction occurs. Then the physical separation enrichment occurs, and which then go to the hydrometallurgical route or pyrometallurgical route. This is basically melting down of the smelting of the metals, and this is basically leaching through acidic solution. The electrometallurgical method includes the electrolytic recovery refining, and finally we get the base and precious metals. The organic part, which are fiber or glass, are separated during the physical separation method. The metallurgical methods include biosorption and I think bioleaching. And the e-waste recycling in India was discussed, in which we got to know that India is one of the only Southeast Asian country which has the legislation for e-waste, and different and research a team from of researchers from IIT Delhi have found a sustainable method to recycle and manage the e-waste. Now we will discuss some sample questions related to the assignment tell, which will help you in solving the 12th assignment. So first question is the air pollution caused by gaseous pollutants can be controlled by using fabric filter, gravity settling chamber, or combustion or cyclone separator. Can anybody give me the answer for this?
Fabric filter.
It is written air pollution caused by gaseous pollutants. Now, how can you control the gaseous pollutants? Can you control it by fabric filter? Gaseous pollutants such as NOx, such as SO2, such as carbon monoxide. So different options are given here. Can it be fabric filter? Do you think so?
I told fabric filter, madam.
Sorry, but it is not correct.
There.
Fabric filter is used to control the pollutants, particulate pollutants. Okay,
Okay, okay, okay,
the
madam.
it is used for filtration. So filtration
Huh.
have small pores, and the particles of some certain size are entrapped into these filters. So filters are
Okay,
basically for removal of solid particulates present in the air. So fabric filter is used for that. Gravity settling chamber is also for particulates. Cyclone separator also for particulates. Same is fabric filters. The only option remaining here is
combustion.
combustion. So if you have different pollutants such as carbon monoxide or hydrocarbons, you can combust them and form a less toxic product.
Okay.
So next question: the application of oxygenated additives in gasoline reduces the emission of. These are different pollutants given here. So if you add oxygenated additives to gasoline, what will result in the what pollutants do you think would reduce in the emissions? So the correct answer here is hydrocarbon and carbon monoxide. If you add oxygenated elements in the gasoline, so oxygenation of HC and NO is suitable for the reduction of emissions. So Hc plus O2 can give us either CO2 plus H2O, and CO plus O2 uh, gives us CO2. So these are lesser toxic pollutants, and this is not a balanced equation. Kindly balance it. So HC and CO. Next question: air quality managers use dash to understand the air quality problem fully. Find the most suitable option from the following to complete the above sentence. So is it emissions inventories or air monitoring or air quality modeling tools or all of the above? So to understand a quality problem completely, one needs to have the emission inventory. So this is a database for all the pollutants which are discharged. The air monitoring as well. So you need to measure the real time concentration of the air pollutants which are discharged. Then the air quality modeling tools also be needs to be there. So all of the above are correct here. As per air quality index, ambient air quality of the Indian city can be categorized into dash categories. What is the correct answer here? Can anybody give me the answer for this? How many categories are there in air quality index? We had seen it can be good, it can be satisfactory, it can be moderate, and so on. So how many categories in total are there? So the correct answer here is six categories. It can be good, it can be moderate, it can be satisfactory, it can be poor, very poor, and severe. Next question. The green index is computed as the arithmetic means of two subindices. So what are the two subindices? Here we are given the first option, it is SO2 or carbon monoxide. The second option is SO2 or coefficient of haze. The third option is SO2 and carbon dioxide. The fourth option is carbon dioxide and coefficient of haze. So which one of the formula here is correct for the green index? Can anybody give me the answer for this? Okay, so correct answer here is the second option, SO2 and COH. It considers the subindices of SO2 and COH. Next question. Find the most suitable option from the following for in-site management of biomedical waste that is not 100% dry or solid. So what is the correct answer here?
Autoclave.
No, microwave. Microwave is the
Okay.
correct answer here. So waste which is not 100% dry or solid can have moisture in it. So the moisture is then used to produce the when it is microwaved, it produces steam which is then used to sterilize the waste. So microwaving is the correct answer here. Okay. Next question, for deep burial of biomedical waste, a pit or trench should be dug about dash meter deeps. So what is the correct answer here? What is the correct option here? Is it 5 meter, 2 meter, 8 meter or 10 meter? For the deep burial.
10 meter.
No, 2 meter. 2 meter is the correct answer.
Just now you saw showed the in the last the pit and all diagram, ma'am. Can you
That
please?
is 2 or 3 meter only. I can show you.
Okay. Okay.
This is here you can see it is the height is 2 or 3 meter. So the correct answer here is 2 meters. Next question. A typical composition pattern for e-waste is, I already gave you the answer. The correct answer here is 30% organics, 30% ceramics, and 40% inorganics. Next question. Carbon monoxide affects the oxygen carrying capacity of your lungs. Exposure to 60 ppm CO for 120 minutes at standard temperature and pressure has been found to impair one's ability to discriminate stopping distance. Thus, motorists in heavily polluted areas may be more prone to accidents. Are motorists at a greater risk of to accidents if the CO concentration is 65 milligram per meter cube? Assume STP. So here we are given the maximum limit for the exposure to carbon monoxide. So this is 60 ppm. And the current concentration of the carbon monoxide in air is also given. So the limit is 60 ppm. This is volume by volume. Okay, 60 ppm of carbon monoxide, and the current concentration, it is given in milligram per meter cube. So it is 65 milligram per meter cube. And we need to assume standard temperature and pressure. So standard temperature is 273.15 Kelvin and pressure is 1 atm or 1.01325 into 10 to power 5 Newton per meter square or Pascal. Okay, so now we are given the limit and we are given the current concentration or the given concentration. So this is 65 milligram per meter cube. So we need to either calculate this 60 ppm to milligram per meter cube, or this milligram per meter cube to ppms. And then we need to find out whether this given concentration is either lesser or higher than 60 ppm. So what we can do is we convert limit ppm to limit in milligram per meter cube. Okay, and then compare with given current concentration. Okay, or we can go, sorry, or we can go given it is milligram per meter cube, we convert that to given concentration in ppm, and then compare with the limit, which is in ppm. So you need to have same units so as to compare the given concentration to the limit. So we go by this route. Okay, so we are given the concentration in, it is 65 milligram per meter cube. So we need to convert it to into ppm. So this is we take basis as 1 meter cube of air. So given concentration is 65 milligram of CO in 1 meter cube of air. Okay, so what will be the, for in 1 millicube of air, how many moles of CO will be there? So that will be 65 into 10 to the power minus 3 upon the molecular weight of CO. So molecular weight of CO is C is 12 and O is 16. So we get 20, 28 gram per mole. Okay. So this is 65 into 10 to the power minus 3 gram of CO, and this is 28 gram per mole per meter cube of air. So we get 2.321 into 10 to the power minus 3 moles of CO upon meter cube of air. Okay. Now we know the moles of CO. Now through PV is equal to nRT ideal gas relation, we can find out what is the volume of these many moles. So volume of CO, that will be nRT by P. Okay. So here we know 2.321 into 10 to power minus 3 into R is 8.314. I am taking here 8.314. This is in joule per mole Kelvin. Okay, and 8.314 into temperature. So STP is given here. So 273.15 upon pressure, which is 1.01325 into 10 to power 5 Newton per meter square. So here you see these are all consistent units, and accordingly the gas constant has been taken. So joule is basically Newton meter. So Newton gets cancelled. Okay, mole, these are moles, so mole get cancelled with this. Okay, and this is in Kelvin, per Kelvin, and this Kelvin gets cancelled. This meter square comes above, and this meter square comes above. Uh, just a minute. And this is meter, so this becomes volume. So we get here meter cube of CO per meter cube of air. 5.201 into 10 to power minus 5 meter cube of CO per meter cube of air. So this is volume by volume, 52.5.201. Okay, 10 to power minus 5. We go to the next page. So we shift the decimal. So this becomes 10 to power minus 6. Sorry, and this is equivalent to 52.01 ppm of CO. So the maximum limit here is 60 ppm. So are the motorists are at a greater risk? No, because this 52.01 is less than 60. So not at a greater risk. And here the answer is given. So here some correction is there. So this will be 5.201, and then we get here around 52 ppm. This will still be less than 60 ppm, so not at a greater risk. Okay. Next question. Typical biomedical waste. BMW is biomedical waste, has a moisture content of around 30%. And roughly 8% of the dry mass of BMW is hydrogen. Using the high heating value of BMW, 13902 kilojoule per kg, estimate the latent heat of vaporized water. So here we are given that we firstly take the basis. Okay, basis is 1 kg of BMW. As we are given different concentration of the contents in the BMW. So we are given roughly 30% is around moisture content. So moisture will be 0.3 into 1, 0.3 kg. Then the dry mass, it is 1 minus 0.3, which will be 0.7. So 0.7 kg. And of this dry mass, 8% is hydrogen. So hydrogen is 0.08 of 0.7 kg. So this is 0.056. Yeah, 0.056 kg. So now we know the mass of hydrogen, we know the mass of moisture in 1 kg of biomedical waste. We need to find out the latent heat of vaporized water. So we were given the formula as QL is equal to 2440 into W plus 9H. So this moisture is basically W and this hydrogen is H. Okay. So W is kg moisture per kg BMW or kg waste, and this H is kg hydrogen per kg BMW. So we plug in these values. So W is 0.3 and 9 is a factor to be multiplied with H. So H is 0.056, and then we get the answer as